Alright, welcome back. So again, with the last example, we actually found 6 different equations, all that describe the exact same graph. And if I wanted to extend it out further, I could find infinitely many more. Okay, the one thing about periodic and sinusoidal functions, because they repeat at regular intervals, you can get infinitely many equations that all describe the same graph. So I'd like you to try and do the same thing for this one. I only asked for one sine or cosine, so again, you can choose whether you want a positive cosine, negative cosine, positive sine, negative sine graph. That's up to you. I'm going to do an example of each, but again, if you haven't done so already, please try and get all the key information. I mean the amplitude, the period, the axis, and try and create your equations by finding your phase shift and going from there. Okay, when you're ready to run through the answers, push play, and we'll run through it together. Okay, so first off, check your main features. I got an axis of y equals 2, an amplitude of 5, and a period of 30 degrees. If a period's 30 degrees, that means k will be 360 divided by 30, which is 12. Okay, so I started by creating a cosine graph because I thought it would be a little bit easier. And I created two. You only have to create one, but based on what you chose, you can try and match up your answers. So at first I chose to create a negative cosine graph. So a negative cosine graph starts at its minimum because it's been reflected from the parent function. So I isolate a spot where the function is at its minimum, and I chose this one right here. Again, I could have chosen any other minimum on the graph. I just happen to choose this one. So if I choose here to start the cycle, that means it starts at 20 degrees instead of 0. So it's right 20 degrees for my phase shift. Now for my equation, my amplitude's 5, so that value goes in there. My axis is 2, that becomes my vertical shift. My phase shift is right 20 degrees, so I get x minus 20 in there. My k value is 12. Okay, I chose to make a cosine graph, and the reason I need this negative here is again because I started at a minimum, so it was a reflected cosine graph. Okay, so again, whether it's positive or negative depends on what kind of graph you're making. You need to make sure you choose the right one. Okay, now I also chose to make a positive cosine graph just because I could. So if it's a positive cosine graph, it starts at its maximum, so I chose this maximum right here. It doesn't look like a very exact point on the graph, but that should happen halfway through the cycle, so halfway between 20 and, in this case, 50 over here. So halfway between 20 and 50 occurs at 35 degrees. So if I start here, it's starting at 35 degrees, that gives me my phase shift. So I wind up with positive 5, again positive because it's now a positive cosine graph, positive cos of 12 bracket x minus 20 degrees, sorry, this shouldn't be 20 degrees, this should be a phase shift of again, 35 degrees, tiny little boo-boo there, major little boo-boo actually. So again, my cycle started at 35 degrees, so it'd be right 35 degrees and then plus 2. Okay, so when you're creating a new equation, again, your amplitude, your axis, your k value are going to stay the same. What could change, depending on what kind of graph you're making, is the phase shift, whether it's a sine or a cosine, or whether it's positive or negative. Okay, so if you haven't done so yet, please make your sine graphs, and I'll put up the answers in a second. Okay, so again, I'm making an example of both a positive and negative sine graphs, just so you can compare your answers. I chose, if it's a positive sine graph, it has to start on its axis and go up from there. So again, there's lots of spots where that happens, here, here, over here, and over here. I chose this particular one right here. Now, the x value in which that starts is not exactly clear from looking at the graph, but that should happen, it should be on its axis halfway between the maximum and the minimum, so halfway between 20 degrees and 35 degrees. So halfway between there, 20 plus 35 divided by 2 is 27.5 degrees. So if I want to create a positive sine graph, my shift is going to be right 27.5. So I create my equation. Again, amplitude's the same. It's positive sine graph because I go up from the axis. 5 sine 12 bracket x minus 27.5 degrees, all plus 2. For my negative sine graph, I need to be on the axis going down from there. So again, I just chose this point where it happened, even though there were others. The x value should happen halfway between 35 and 50 degrees. So that's going to be at 42.5 degrees. So that gives me my phase shift. So the equation for this one will be negative 5 sine bracket 12 bracket x minus 42.5 degrees, all plus 2. Okay, so again, lots of different ways you can create an equation to represent this graph. Okay, last one I want you to try from this set here. I'd like you to try and fill in the missing values on this graph, and then from there try and create both a sine and cosine equation. Okay, so start off to fill in your values here. You're missing the axis along the y here, so that's going to be halfway between your max and your min. Halfway between 30 and 12 is at 21, so that gives you my axis there. I can also get my amplitude there. Distance from 21 to 30 is 9. Okay, for my x values here, to find the first one here, I averaged 20 and 100 because this value should be halfway in between them. That gave me 60. Once I had the 60 there, it gave me the pattern here. So it goes up by 40 degrees every single time I go up a quarter cycle. So I get the rest of the values there. Now for my period here, I start at 20 degrees, end at 180 degrees. So it means the whole period is 160 degrees. To get my k value from there, if I want to create an equation, k equals 360 over 160, which reduces down to 9 over 4. Okay, now again, infinitely many answers to get your equations here. I just chose the what I thought were the two easiest based on what was given here. So I create a graph that started right here with a phase shift of 20 degrees. Now this one, it's on its axis going downwards. That's going to be a negative sine graph. So I have negative 9 for my amplitude, sine of 9 over 4 x minus 20 degrees for my phase shift plus 21. So that's one equation. The next one I created, I decided to create a cosine starting from that 60 degrees. So because it's starting at its minimum instead of its maximum, it's going to be a negative cosine graph. So it'll be a negative cosine graph with a phase shift right 60. So I get negative 9 cos bracket 9 over 4 x minus 60 degrees plus 21. Again, these were just two options. I could have, if I wanted to, create a positive sine graph starting here with a phase shift of 100 degrees, or a positive cosine graph with a phase shift of 140 degrees, and those would have been perfectly valid as well. Okay, so again, lots of correct answers here. If you're not sure if yours is correct, please come ask me, and we can run through it together. But based on what was given, I thought using these first 2 points would be the easiest ways to create a sine and cosine graph. Okay, so now changing gears a little bit. So I'm going to give you f of x equals cosine x, and g of x is a transformed version of that according to that equation right there. So before I even think about what to do with this, I don't like having the equation in terms of f. I want to create it in terms of my actual function, which is cosine. So this is going back to the very first unit of the year, and it's something that we still seem to struggle a little bit with, at least I've seen that on our tests so far, is creating equations using function notation. So let's do that here. Before we even think about these, I'm going to have g of x. So it's going to be negative 5. Now, f of 3x plus 45. Remember, f of 3x plus 45 means you take your function f, and your input has been replaced with 3x plus 45. Well, since f is cosine of x, this is going to be cos of 3x plus 45 degrees. And then I have my minus 9. Okay, so that's creating my equation using the function notation. I didn't give it to you explicitly. I had to do a little bit of work to get there, but that's all it was asking you to do if you wanted to create the equation. Okay, so with that in mind, now let's actually try and answer this. Let's try and find the y-intercept of g of x. Okay, so we haven't done too much of this, but y-intercepts, the process does not change regardless of the kind of equation you look at. If you're putting in the y-intercept, that means x equals 0. Okay, so g of 0 will be equal to negative 5 cos of 3 times 0 plus 45 degrees minus 9. Okay, and we can run all that through our calculator. We'll have negative 5 times the cos. 3 times 0 plus 45 is just 45 degrees. So I have negative 5 times the cosine of 45 degrees minus 9. Okay, so when I run that through my calculator, I get negative 12.54. Okay, which matches about what I got down here. Okay, so again, y-intercept, we haven't done that yet, but again, idea does not change for whether it's quadratic, linear, exponential. Y-intercept, put in x equals 0. Okay, now B asks us for two different but equivalent equations for g of x. Now, here's one equation right here. We already found it when we were just setting up the problem here. So we have negative 5 cos of 3x plus 45 minus 9. Okay, now, in theory, I could create another equation that's equivalent by factoring this out here to get my phase shift a bit more explicitly. So I have negative 5 cos, and if I factor out the 3 here, I'm going to be x plus 15 degrees minus 9. But let's see if we can create an equivalent one using sine instead. So let's take a second here. Let's make a sketch. In fact, I'm going to let you make the sketch. And once you have the sketch, try and create another equation that's equivalent to this, but instead of being in terms of cosine, have it be in terms of sine. Okay, so give that a try, push play, and you're ready to see the answer. Okay, so there's your graph of what's there. So I've got my period being 120 degrees, got my x and y values, and created my sketch. Once you do a lot of these, you'll become a pro at this. You just got you'll be able to create a sketch in just about a minute or so. So to create an equivalent equation, again, if I want to create one using sine, I got to choose a point where the graph is on its axis. Let's say I choose this one. This will be a positive sine graph if I start my cycle there. So that means my equation will be, well, I'll use g of x. So if g of x equals, if it's a positive sine graph, I'll have 5 sine of 3x plus 15 degrees. Sorry, won't be x plus 15. Let's try that again. So it's going to be positive 5 sine of 3. Now, if I'm starting here, it's starting at positive 15 degrees, so it'll be a phase shift right 15, it'll be x minus 15 degrees. Okay, I always want to make a note here of your phase shifts, so you don't make a mistake like I just did. So right 15 degrees, and then I go minus 9 for my axis. This is another possible equation in terms that's going to be completely equivalent to the one we just had. Okay, last but not least, let's take a look at C, where it says two solutions to the equation g of x equals negative 14. Now remember your function notation. If g of x equals negative 14, that's the same thing as solving y equals negative 14. Okay, so on our graph here, y equals negative 14, well, we can see two answers on our cycle right here. One of them right here, and one of them right here. So you have two possible answers when x is negative 15 degrees, and once again when x is 105 degrees. Okay, so again, just some other things we can do with sinusoidal functions. Okay, let's take a look at a more typical real-life example here. So we have a Ferris wheel that rotates every 40 seconds. We have the highest point above the ground. We have the radius. We know the passenger's board at the bottom, and the ride starts and everyone's on. You're the last passenger to board. What I'm going to have you do before you even start doing anything with solving this is try and create a sketch of the situation. Try and use the information that's there to try and find the highest point, lowest point, middle height above the ground, and see if you can figure out values along the x and try and create a sketch. Okay, so push play and ready to see the answer once you've tried representing this in a graph. Okay, so here's what my sketch looks like. I'll tell you how I figured it out. So we know it takes 40 seconds to go through. So we start at 0 seconds, land 40 seconds later, which means halfway through the ride, it's at 20 seconds. You can fill in the other values, 10 and 30 from there. Now, for the y values, we know the highest point's 41 meters above the ground. Since the radius is 20 meters, it'll take 20 meters to go from the top of the ride down to the middle height above the ground, which will be 21, and then another radius of 20 to go down to the smallest value, which is 1, which kind of makes sense. Need some sort of gap between the bottom of the ride and the ground, or else you might lose your legs. It scrapes them across the ground. So once we have that in mind, we want to try and find the height after 25 seconds and after 3 minutes and 10 seconds. Now, 25 seconds you'll see is not a particularly nice value on the graph. We can't necessarily get it exactly. So to get it exactly, we have to try and create an equation. So take some time now, and again, on your own, I want you to create an equation. It can be sine, can be cosine, whatever you like. Create an equation for this graph, and then we're going to use it to solve A. Okay, so again, I started labeling all my information here. So my period's 40 seconds, so 360 over 40 gives me a 9 for a value of k. My amplitude is 20, going from 21 to 41 is a distance of 20. My axis is at y equals 21. Now, to make my graph, I chose to use the starting point right here. So it starts at its minimum, so that'll be a negative cosine graph. The nice thing about choosing this point as well, because it starts at 0, there's actually no phase shifts. The equation is a little bit nicer to work with. So I wind up with h of t. I called h being the height, t being my time. So it'll be negative 20, again, negative is a negative cosine graph, negative 20 cos of 9t plus 21. Okay, and we're going to use that now. Now that we have an equation, we can find our height for 25 seconds exactly. So what we're going to do is we're going to take 25 seconds, throw it into the equation for t, and then we're going to solve for the height. Okay, we're actually almost done this lesson here. Looks like I'm going to have to continue this into part 3, but it won't take much longer than a couple minutes to finish that up over there. So try and run this through your calculator so you can get an answer, and then we'll finish this one up in the last couple of quick little examples in part 3.